Hi, I'm Cbse.
Hi, I'm Praneet.
We are from Tamara International School, bringing the project titled Water, Water Everywhere, All the Drops to Irrigate. We belong to Tanjavur, and agriculture is the backbone of our society. Our Delta district is totally dependent on the river Kaveri as the primary water source. When there is heavy rainfall, the surplus water drains to the sea and thus result in wastage. On the other hand, during droughts, the river Kaveri will not have sufficient water for irrigation because it's a non perennial river. When this rainfall escalates into a flood, the stagnant water will not permit the crops to respirate and thus they will start to decay and die. Till date, there is no solution for this problem, but we took effort to find a solution through our project.
We met and asked a few farmers, and they have proposed two problems. One is too much rainfall, and another is no rainfall at all. We have a solution for both of those problems in our project. The first problem is encountered with the help of our rain alert system, which alerts the farmer with the help of a buzzer, LED, and a display. And when this rain escalates and continues over a long period of time, it may become flood.
And because of this flood, if the water level increases above the predicted value, our drainage system will activate and then drain the water to the underground storage tank, which is placed right beneath the field.
In an instance, when the soil is dry, the soil moisture sensor detects it and sends and starts the motor pump, which starts irrigating the whole crop field when there is no rainfall or the monsoon fails. I would like to show you a stat if this project is implemented in real life for 1 acre where paddy is sown. We need 20,000 liters of water to irrigate at every 3 days. Paddy may require a minimum of 105 days to harvest. 105 divided by 3 equals 35 times of irrigation. Into 20,000 liters equals 7 lakhs liters. In that 7 lakh liters of water in that 1 acre, we are going to use only half the space to place storage tank. This is a model of the storage tank, which is a horizontal cylindrical tank which is 100 feet long and the diameter is 7 feet, and we are only going to fill about 6 feet, which means it can store about 1 lakh liters of water. Totally, 10 horizontal cylindrical tank can store up to 10 lakhs liters of water. Our minimum requirement is only 7 lakh liters minus the 10 lakh equals 3 lakh liters of excess water.
Now, you might have a question that won't it cost much? Yes, it won't cost much because we also have another idea for that. Yes, humans are wasting so much plastic every day. For example, and research shows that a human wastes about 2 kilograms of plastic every day, and that roughly makes up to 800 kilograms per year. So, what do we do with that waste? Have you ever thought about that? Now, we have another way to bring it together. Yes, morning we use the brush, we have casing for everything. Even if we open a packet of tomatoes nowadays, it's having a casing. All these plastics can be gathered together, and also our office users and stationary users are using so much plastic. As well, the medicine. India is filled with medicinal plastic. We can all bring that together and then make a storage tank which will be more cost effective and bring another life and create this project much cost efficiently. Now, we are going to see the working demonstration of the prototype of our idea. First up, we are having the DH11, also known as the temperature and humidity sensor. It will show the temperature and humidity in the display over here. Next up, we are having the rainwater sensor, which will detect rain, and then it will show us alert in the buzzer as well as light, and it will show that it's wet and it's raining. Next up, we are having the wiper, which will wipe the stagnant water left over in the raindrop sensor. And then once the rain stops, it will show that dry, no rain is there. And then if this rain continues and becomes heavier, the water level will gradually increase, and thus the float switch will also increase. This will pass and signal to the Arduino Uno, and the Arduino Uno will process the signal and pass it on to the relay module. The relay module will give and way the relay module will give and way for the solenoid valve to open. And over here we are also having a buzzer and a LED light to show the flood, whether there's flood or not, and it will show the volume of the flood as well as whether it's open or not. And then we also have a wiper over here to wipe off the excess blocking part before the drainage system. And then after the solenoid valve we will be having a water flow sensor, and the water flow sensor will give us the value of how much water is being dispersed. And then at the end also we'll be having another water flow sensor which will bring it to the underground storage tank, which is kept right under the field. Next up we are having the underground storage tank, and if the water increases in the underground storage tank, the same type of sound and LED will be shown to say that the maximum amount of water is being dispersed. After this, for the dry season, this is also the second part of our project. In the dry season, to identify dry, it will show us dry, and then the next stage it will gradually increase. It will gradually increase, and then in the next stage it will be up to its maximum level. So with this we can know whether it's dry or not.
We hope this project helps all the farmer out there. Jai Hind.